Okay, so here we have a practical calculus problem to find the maximum area of a corral that a farmer or rancher wants to build, and they only have 400 feet of fence. So, what are the dimensions of this rectangular corral that they can build such that they use all of the fence? Okay, so we're going to solve this with two equations in two unknowns. And then we're going to use calculus to find the maximum area. And the way we do that is we take the derivative of the formula for area with respect to one of the variables. We set that equal to 0 to get the max. We solve for that variable. We plug in and solve for the next variable. And that'll give us the answer. Okay? So let's figure out what the area of this will be. The area of a rectangle is the base times the height, and the base is 3x, and then the height is y. So that's going to be our formula for the area. And the formula for the perimeter, which is 400, is going to be 1, 2, 3, 4, 5, 6x plus 1, 2, 3, 4y. Okay? So we now have our two equations and two unknowns. So basically, these two equations, we're going to solve this equation here for y. So we're going to get 6x plus 4y equals 400. And that means that 4y equals 400 minus 6x. And that means y equals 100 minus 3 halves x. And we're going to save this equation. We're going to use it again. So let's take this equation and put it into this. And so we have a equals 3x times 100 minus 3 halves x. And that equals 300x minus 9x squared. Sorry, minus 9 halves x squared. So that gives us y, or a. So that gives us a equals 3x times 100 minus 3 halves x, which equals 300x minus 9 halves x squared. Now, we take the derivative of a with respect to x, which we'll call a prime. That is going to equal 300 minus 9x. Okay? Now, to find the maximum, we're going to want to set this equal to 0. So we're going to solve this. We're going to say 0 equals 300 minus 9x. And that means x equals 300 over 9. And that equals 33 and 1/3. Okay. So if x is 33 and 1/3, then we can now use this equation to find y. So then y will equal 100 minus 3 over 2 times, we'll call it 300 divided by 9. And that will be, this will go to 3. This cancels here to 3. This cancels here to 100. This cancels to 50. So this reduces down to 50. So y equals 50. 100 minus 50 is 50. So the dimensions of the field will be 50 here, and then 3 times 33.5, which is 100 here. So the field will be 100 times 50, 100 feet wide. Each one of these will be 33 1/3. So you get 3 corrals, equal size, 50 on this side, and then the whole thing is, each one of them is 33 1/3, and the whole thing is 100. So that's a practical application of calculus using maximum and taking derivative setting, zero solving, and 2 equations, 2 unknowns to solve a pretty interesting little problem. So if you like this, please hit the like, and please subscribe to my channel so I can show you more videos. And if you hit the notification bell, you'll see when I have them available. So thanks for watching, and we'll see you in the next one.